Yes. Okay. So I guess. Anyway, so I don't know if anyone has read this before. I haven't, so I'm planning to just go through it and people can comment stuff for us while we are doing it. But if anyone else has read the paper and wants to explain it, they can also. But I'm going to bet that's not the case.
Sorry, I'm not talking because I'm eating. But yeah, I'm just listening. So I'm happy to have you go over the paper. I haven't read it.
I'll go over the paper. So I haven't read it, but I do know that it's okay. Let me just start by reading the abstract out loud. Sparse encoders are a popular technique for interpreting language model activations, and there is extensive recent work on improving sparse encoder effectiveness. However, most prior work evaluate progress using unsupervised proxy metrics with unclear practical relevance. We introduced sparse encoders a comprehensive evaluating suite that measures certain code performance across diverse metrics, spanning interpretability, feature enhancement, and applications like learning. To enable systematic comparison, we open source a suite of over 200 sparse encoders across 8 recently proposed sparse encoder architectures and training algorithms. Our evaluation reveals that gains on parameters do not reliably translate to their practical performance. For instance, while master's sparse encoders likely underperform on system proxy metrics, they substantially outperform other architectures on feature syntactical metrics. This advantage grows with sparse encoder scale. By providing a standardized framework for measuring progress in a sparse encoded environment, sparse encoded enables researchers to study scaling trends and make nuanced comparisons between different sparse encoded architectures and training methodologies. Interface enables researchers to visualize relations between hunters of this way. I'll open a interface. I haven't seen the way it looks. That's maybe. Yeah. Looks nice. I guess we can look at it later. Yeah, I think just like reading the abstract, I do think there are nice things about having some unsupervised metrics like reconstruction loss and things like that. I understand why you want to test if it's actually useful, but I'm not sure how good that is, especially because maybe there are some things the sparse encoders might be used for that people are not the things that people have thought of using them now because we just don't have the sparse encoders and especially if I exactly what the tasks are, but if you're just doing things like stealing and things like that, maybe there is something like, for example, Anthropic has this new we'll probably cover next week where they do those nice graphs with different features to find circuits that do specific things. And I feel like there is nice things that sports encoder or sports encoders like things can be good at that might not be captured by this. But we'll see exactly what I need to see what the benchmark is about. Like I guess this thing, I do agree that maybe that this can work as a like you find that the current metrics correlate much with usefulness. It might be that the metrics are just bad. I do feel like it will be nice to have a actual metric that it's a single number that you can optimize for, and if it's good, models are the sports encoders are good. Feels like it might need that in small interpretability in a sense with something less sports encoders. But yeah. Anyway, that's just my thoughts on the bro. Is someone else wants to say something? Otherwise, I'll just grab it at the introduction of that. No diseñé, so I'll keep going. Free to and anyone just interrupt me to say something. Okay. So how can we evaluate dictionary learning for language model interpretability? Sparse encoders are a popular method. Yeah, this is the usual link to all the previous work part of the paper. Someone?
Yeah, I have a question. I have always read about this dictionary learning, but it's always closely linked to person encoders. So I don't know if there are other type of dictionary learning that are popular, or it's just like a synonym.
I don't know, to be honest. I think that's an interesting question. Dictionary learning is like the problem in abstract. I do think that maybe there is some other techniques that people haven't tried with the broad literature related to dictionary learning. Oh yeah, someone put something on the chat about this. There is orthogonal proximal mappings.
Yeah, there's like other types of dictionary approaches. It's just sparse autoencoders are really scalable, and that's why we use them.
Yeah, that makes sense. Do you think there's any other, simple thing in the the dictionary learning literature that people just haven't tried?
Not that I know of. I mean, people have tried orthogonal matching pursuit in a couple papers I've seen. And of course, like, I don't know what they call it. Like, they might call it instead of calling it like dictionary learning, they might call it like some other terms. Like there's a synonym to dictionary learning. It's like the same idea. But I don't think they've ever. Let me see if I can't find the paper. Maybe this is
because I'm wondering like how much people have tried sparse encoders because they were scalable and a simple thing they seem to work, but now people are finding that they don't work. I wonder how much, like, maybe there is a bunch of things that in the broader machine learning literature or statistics or whatever literature that could work. People just haven't tried because they are not that aware of it, and they were for some coders. And maybe someone can just, someone who has read a lot of papers on the topic can just say, oh, if you try whatever instead of person coders, and that just works, or like maybe it's interesting seeing which things don't work or work worse, for example. But maybe you can try other ways of decomposing the weights and see, like, compare them on this benchmark. But yeah.
Yeah, I don't know. I mean, like, I think didn't we have that? And this is like a long time. I don't know how long it's been since I've last been around. But they had that paper where they, I guess, they kind of forced the neural network to follow like an implicit bias towards
linear stuff.
PCA. Yeah.
Oh, PCA. I'm not sure. I don't remember the exact paper. You should just ask. But
Yeah, I know what you're talking about. Just some type of matrix decomposition, right? Like just.
yeah,
Okay.
I mean, there is a recent thing where they decompose in linear and quadratic functions and that models. Quadratic approximation was good. Like at some point, the linear approximation was good, but at some point it stopped being good.
Yeah.
But I think for talking to Wood about this on the reading group, I think that the take is that it's a cool theoretical result, but not very useful. So I don't know. The approximation is like exponentially big with the size of the network. They are not summarizing the network. They are like making a really big quadratic function that have the same result as yeah, I don't know how useful it is, but it may say something about what kind of approximations, like what kind of person coders might work.
Yeah.
But,
I mean, also, I feel like this bench doesn't explore things like, I don't know, I haven't read it too much to it yet because I've just been busy with grad school, but like transcoders, like these other things where you're kind of hooking up multiple layers together, right? I'm assuming this paper only does single SAEs, right?
I don't know. We'll see. Maybe they have transcoders on the that's the the Matryoshka ones. But I'm also curious about that, about transcoders and all that. I still work at the transcoders and he's on the transcoders paper and he's on the reading group sometimes, but I think he's not clear right now because it's last week. But yeah, I guess we can keep reading and we'll see that. That's one of the main things I'm curious about. Okay, so I know person coders interpretable. Yeah, this is just typical stuff. Like sparsity and fidelity. Yeah, sparsity is nice, but doesn't completely work because there is feature absorption. Yeah, this composition interdependent latent thing, and recently there is some papers about how there is some high frequency features that are actually meaningful, and having training with sparsity makes the model not learn them very well. Yeah. This is some.
Sorry for interrupting you. I had another question. What is high feature latence?
Sorry, can you repeat that? I didn't hear you very well.
I was thinking about high frequency latence.
Frequency latency is like the. I mean, on the encoder, there are some latent features that activate with features, meaning they activate some mouse inputs that seem to represent things like the positional encoding or there are some like this the means things like this code is some is Python code or this is some numerical text that exists on like instead of firing only on the text that happens so that happens to do that like there is a negative version that means that the text is not that kind of text that exists of most text. So if you want to use sparsity, you have the assumption that you can summarize the activation in some small number of variables. You're going to have a problem if there is some variables that are always active or active most of the time. Well, yeah, it's going to have problems. So that's just basically that. Just related on the spark that activates with high frequency most of the time. There is a paper that we read on the reading group recently. No, I don't remember the name, but it's on the previous reading groups.
Okay, I will check that paper.
Yeah. Oh, I found it. It's high frequency layers are feature notebooks. So I should check this paper. It's recorded like the review group with the authors coming on the the here and go. So, yeah. Anyway, I going if nobody has more things to say. Look at this. I think it would be very nice to have a single idea medic. But if we have that try doing this kind of having a bunch of metrics can be okay. I guess it might be cool to look for some metric that correlates with all of the other benchmark ones. That might be some way you can find something that's better than sparsity to track sparsity colors. But we'll see. The detection, interpretability, feature entanglement, and construction. Ajá. So, main contributions are they have the person code bench and they have the benchmark and they train a lot of person coders with different architectures. Yeah, we are curious. Those architectures include things like coders or not. And there's also this recent. I haven't looked into it, but there's a cross coders thing that they were talking about in the DeepMind blog. Yeah, I haven't don't know much about that yet. So yeah, I wonder if they have like, tested some. If not, maybe that's a paper idea. Here, right? Yeah, this is just related work. Yeah, there's a bunch of switches, okay, patch.k, Ayonrinde, whatever, a bunch of different codes. Lots functions. Yeah, different network structure. Yeah, but they don't mention structure code or anything. So, yeah. I guess I need to ask Gonzalo if he thoughts on that. But yeah. Renovations. previous simulations have frequently focused on specific aspects of performance. Automatic interpretability have been adopted. I think the automatic interpretability is pretty cool. Yeah, like it feels like it's maybe just waiting for better language models that are, better at distinguishing the thing. But I like that way of using models. Like the Mech is not that necessarily that good. The models might just be bad at figuring out like the interpretation. But I think it's cool the idea of like checking the explanations to match the actual activations as a way of testing if a text explanation. Like I think the testing if text explanation is good part of the auto therapy.
Victor, yeah, just to be clear, automated interpretation is that a language model is used to define what each latent is activating on.
Yes, like you have a bunch of examples that you just ask ChatGPT or whatever to explain what the feature is activating on, and then you take that explanation and test how much it matches like other examples. Like you put an example, use ChatGPT or whatever large language model to check what example it should activate into the explanation, and then it gets some score based on how much it matches. And I think that pipeline is pretty cool. Like it's the main thing it's missing is large language models being smarter, and that's will just happen. We just need to wait for that to happen. So, yeah.
I always felt like, if we're going to talk about evaluating SAEs, part of me always was like, for what? Like, if I'm trying to interpret a bunch of medical features, it would be really nice if all of the features in my dictionary are very relevant to the medical feature. I wouldn't care about, features that are not related to the medical space, right? So maybe I wouldn't care about cars or dogs or whatever. I've always wondered, like, could you hand annotate, the features you want to see with your SAE, right? Like, I'm trying to interpret how Claude does like a medical diagnosis. Here are the specific medical concepts that I would really, really want to see, right? And if my SAE doesn't do that, then it's not useful for my these predictions, right? Because you could have just one giant medical feature that's activated every time something medical happens, right? That would be a bad SAE.
Yeah, this is very interesting. Yeah, sorry, I just wanted to say, I think that specialization of the SAE is done directly by that's used to train the SAE, right?
Yeah, it depends on what you train your SAE on. Your SAE could be poor for whatever reason. I don't know.
Yeah. I guess if you have a pretty good idea of what features you want to find, you can just do probes. Like the point of using sparse encoders or something like that is to have an unsupervised method of finding features, because you don't know what the features are exactly. You might want something medical and then you can train medical text, but you don't know exactly what kind of medical concepts the model will learn. Maybe there is some weird medical concept that the model figures out that you didn't know about. And
I guess my counter to that is I like the compositionality of these dictionary learning approaches, right? Like I have talk about like a medical knowledge graph with UMLS, right? And I have 3 million concepts. Okay, I can train 3 million layer probes for my large language model, right? But it's not clear to me like what those might be composed of. If I want to train like sub SAEs, or I want to train SAEs on top of my SAEs, and maybe trace the whole circuit. Those are just like naive.
yeah, sense. So, I think at some point, the medical concepts may be like the medical things. Other be using some more general circuits. In the end, you might end up have to do the full sparse encoder that explains the model itself to explain the medical things. Because maybe, I don't know, it uses some chemistry or something, or it uses some reasoning or whatever. And in the end, you might just need to explain everything, and the model might not be as modular as you can just separate the medical parts or whatever. But yeah, I don't know. Maybe.
Yeah. I just think at the time, that's how I would right now. Just like there's some medical malgraph, some giant one, just like can I directly compare these features? Like what percentage of my features when I train an SAE on like some medical purpose, can I directly map to my knowledge graph? Something a doctor would use, right? Like that would be really interesting.
Yeah.
Practical.
I guess maybe you just need to wait a bit until you can just tell Claude or whatever to do the project.
Right.
But I think this favor.
we can write a paper on that too. Benchmarking.
The previous thing, like someone mentioned one of the questions I was asking about if someone had tried using like BQA, like the quantized operational encoder on this, and I don't know, I don't see why not. Like they can just try and see what happens. I feel like a lot of things people just haven't have time to try most things. And maybe like there is some already existing kind of autoencoder or something that would just or like at least work better than the current one. And I don't think people have at the scale both things. So if someone wants to has time to do some experiment, they are asking if some kind of thing might work or not, I will tell them to just try it and see what happens. But anyway, I guess I'll go back to the paper and try to get a bit for them to it. Special code is integrating. Yeah, this is just explaining encoders. This is just explaining the concept of evaluation. Yeah. Also, they do talk here earlier. They talk about using this to pick the sparse encoder for your task. Like you may have a lot of benchmarks. Maybe you have some benchmarks for medical stuff, and there's a lot of different specialized sparse encoders, and you just pick whichever has the best medical scores. At the same time, maybe that's not how it works with language models either. In language models, you just pick the model that is better than everything because there is like benefits of skill. Just train a big model of everything and that works better than training on only the thing you out. But, anyway, comprehensive benchmark. These are nice things about their metrics, typical paper stuff. Okay, this is like a summary of what they have. Absorption, sparse probing, interpretability, yes. I don't think it's like interpretability is automatically produce the best way of finding it. It has some problems, but I guess the only alternative is just paying a lot of humans to do it manually. So yeah, using a system called it has these problems, but it's probably going to get better as models get better each day.
We have preference model for this.
I mean, maybe there is a point where models are generating some weird text explanations that we just don't understand, but somehow the model understand it does get a high score on other things. But I guess that we already will see that there is something there. But yeah. Reconstruction. There's just typical reconstruction loss. For disentanglement, they have unlearning. I don't know what Ravel is, but we'll read for that, I guess. Target correlation and spurious correlation removal. I guess this target probe function is just a fancy way of saying this thing or something. I guess we'll explain later. Metrics. That's the thing here. This thing. The session how individual latents correspond to meaningful concepts to sparse probing features as absorption. Interpretability evaluates the human understandability of layer latents using alarm. I think this is more measures the alarm understandability of latents, but it's a proxy for human understandability more or less. Reconstruction, this is just the thing that people usually train the coders on, how to reconstruct the data, the activations. Feature disentanglement. This is the proper separation of independent concepts through learning. It's spurious correlation removal and proper reproduction.
What do they mean with targeted proper correlation? Do you know?
Correlation thing. I don't know. I guess the spelling more on that section. It took a trade-off between sparse configuration. Yeah. Automate interpolating. I'm wondering, can you just maybe you can, I wonder what happens if you take all of the metrics, combining a single metric with some weights or something, and train a model on that. Maybe that's not very efficient because the interpretability ones will be pretty expensive to data score feed, I guess. Maybe with others, you have to see what the others are exactly.
Do you know if somebody has tried using reinforcement learning to human to create that interpretability that is neural network?
I mean, I don't know how that will work, so I don't think I see anything like that. But yeah. The vision is positive. Okay. Interpretability. Yeah, just they talk about that. Sparse probing. I'm curious what sparse probing is exactly. Sparse probing evaluates whether sparse encoder isolates very specified concepts. For each concept, we identify the K more relevant latents by comparing their mean activations from positive versus negative numbers. Thus, latents at the probe accuracy will be high even through the sparse process was not space supervised to certain points. Okay, so yeah, we find the latents that are more related to some concept and try to see if the how accurate the training a probe on the latencies. There's some papers about training probes on latency, and there is a bunch of problems with that. Like trying to do steering with doing probes capabilities. Yeah, with normal person calls that doesn't work that well for some reasons. But I think that's a cool.
I think the Google DeepMind latest announced that they are prioritizing research. They tested a lot of K-sparse probing. I think the result is that the non-probing classifier is far better than doing the curse. The essay
Yeah,
probe.
I think that was doing steering with sparse encoders maybe, and not accuracy. But yeah, that's related. That the normal probes work better. It does seem a good metric of how sparse encoders are. I think if it has a really good decision necessarily. Yeah. I guess we could be wrong in wrong way about maybe the model doesn't represent the concept in the way we are thinking about it, it's representing some other way, and this doesn't work, but not because of that. Or like the concept is encoding some non-linear combination of latents. But yeah, I think there are some ways that sparse kind of may not be a very like we could imagine some really good sparse encoder kind of thing that works perfectly, but was badly at that. For some, especially to pick the broad concepts. But yeah, what's Ravel? Let's see. Encoder effectively stores independent concepts. It should be encoded by dedicated latents, achieving clear disentanglement. To measure this, we implement Ravel, which is resolving attribute value entanglements in language models. I see. For this paper, which tests how clean interpretability methods separate related attributes within language models. Okay. Works as follows. Given prompts like Paris is in the country of France, people in Paris the language French, and Tokyo is a city. We encode the tokens Paris and Tokyo using the sparse encoder. We train a binary mask to transfer latent values from Tokyo to Paris. The code modified latents and insert them back into the residual stream for the model to generate conversions. Final disentanglement scores average two metrics. Cross metric attribute changes to the intervention and the isolation metric. Define minimal interface with the attributes. I don't completely understand how this works, but okay, let's just keep going. I basically trying to see if you use this model to do replace things by only replacing the thing you care about. I guess in this yeah and that feature absorption. It's a feature absorption is a phenomenon where scarcity device sparse encoders to learn decimal feature representations. This occurs with hierarchical concepts. It implies than learning separate letters for all contexts, person coders is incentivized to learn a letter from A and a letter from B except A to improve sparsity. Features also manifesting under unpredictable ways, creating getting under letters where, for instance, start with S feature may activate on 95% of first starting tokens, but inexplicably of percent where the feature has been absorbed elsewhere. So like you have an start with the S feature and the S feature and the research feature. So yeah, start with S but isn't a snake feature because when there is a snake, the model uses the snake feature and has like some complicated way of activations. It's trying to use the least latency possible. That's a problem. I think that's a problem. Another indication that the sparsity is maybe not the best metric to train the sparsity encoders. But yeah. So they took a bunch of the original paper metric thing and they just use that as a metric. Okay, unlearning capability. In mathematical calculation, we want to selectively remove knowledge for a language model without disrupting unrelated capabilities. I think learning in general is like a weird thing to want to do. It's cool as a test of isolating parts of the model and see if you can remove it with the rest, like as a side test evaluating. But as an objective, I don't think it's that useful. I think it's that few people will actually use it with good methods. It's just something academics came up with as some imaginary thing that people might want. But yeah, I think want the model to not be to not know about how to make bombs. To not tell people how to make bombs and instead try to get model to not want to do that. They try to make the model forget that bombs exist or something. But that's probably not a good way to use it, in my opinion. But anyway, let's go back to what the paper says. We identify relevant latents by comparing the activation frequency between a form set and a change. Yeah, so they try to do the thing where you have some data set and they try to make the model forget some things from one data set, in this case biology things, and without breaking the model in other ways, like the model still remembers wiki text. This session there was metrics that already exist in some papers, but they also use novel methods with my team. Cool. Yeah. Simply and cleanly, some questions within the personal items. Besides, existing models, like learning and retrieval, can modify behavior through the steady Eoin concept are distributed across many layers, stating a few key latents can be split to alter model behavior. Our matrix instead uses zero ablation, which provides a stronger test of constant isolation. Only when we are defining all latents will zeroing them out completely remove the constant. Does it mean normally zero ablation of by the idea because it messes with norms and averages and you should be ablation instead. And maybe in this case is not as good an idea, but yeah, I know what subtle. I will have to add them. Oh, new point. Just going through the paper. I see when I started. I just went through the paper, but feel free to stop me at any point.
I think feature absorption that was a modified metric and this completeness and isolation that they are proposing are very correlated, I suppose, right? I want to know how they are trying to measure it.
Can you repeat your question? Because I know I didn't hear all of it.
I was trying to say that feature absorption is kind of related to this completeness concept that they are introducing, that all the possible features are represented in the style, and
Yeah.
I think it's with completeness and feature absorption.
I guess whether content is fully captured by a small set of layers. I guess it's related, yeah. In that if you have feature absorption, that might be a way that the concept is not fully like it's capturing in more latent because a smaller latent is absorb the latent we care about and it's increasing amount of latents. Yeah. Whether different concepts are encoded by different groups. I guess it's also mess with this isolation because you have some concept that is represented in some way at same latent. Yeah, like you have. Yeah.
I think it's kind of even difficult to define that isolation because imagine you want a feature that activates with Japan and other with but Japan are related concepts. So how are you going to isolate those concepts?
I feel like a lot of these things require you to make some assumptions about how the model should represent things. A question of, maybe you are blaming something sparse to encoder, but the model itself doesn't make the distinctions you are making. Previous collection model. The shift method from this. Yeah, what's these are? This paper started with a biased linear probe classifier that has both intended signals like profession and spurious correlations in gender. And then we measure how effective zero number of person coded layers can remove the unwanted correlations from the person coded. If these layers cleanly isolate the spurious concept, removing them significantly improve the classifier accuracy in the intended signal. I guess the kind of thing that requires you to know what's spurious and what's the that's in like what an actual signal, and that's a lot of another example of testing sparse encoder by having some preconceived idea of what sparse encoder the model should represent, and checking that might be a bad idea in some cases. I don't know. Targeted probe perturbation. Generators, these are probe multi-class settings. For each class, we train binary classification probes and identity monitor labels. We then measure how zero latent these latents affect probe accuracy of recursion. Yeah, so check a bunch of concepts, which you are guessing that those concepts exist, and check how much you can find latents, like how much you can separate latents and where you can delete that latent and see if that affects other. I think this again has the problem of maybe the model just doesn't, like the first encoder is doing his job making the distinction the model is making, and like I don't know, you have some notion of okay, classifier for fish, and you put a whale, and you wanted to say no because the whale is a mammal, and instead the model was having just had a feature. It didn't have a feature for mammals, just had a feature for sea animals or something. No, sea living beings or whatever, and doesn't divide things the way you are doing, and this feels big that even if the first color was perfect. But I don't know how much that's a problem in practice. Prediction guide. When evaluating new sparse encoder methods, we recommend training multiple sparse encoders amongst a range of possibilities. I see some real
earlier.
Oh, I have I'm going through the paper and people are just commenting stuff while yeah, feel free to at any point just stop me and ask questions or say anything you find it interesting. I just reading the paper out loud and talking about things that I find while doing that. If you are interested, you can also watch the recording later. But it's also streaming. They use sparse encoders to evaluate a suite of both common and novel. Wait, so this thing, they recommend training up multiple sparse encoders of different sparsities with deadly comparable baselines. Many evaluations have a strong correlation with sparsity, making sense to others' performance across multiple levels. This approach ensures the improvements are generated the statistical noise. Furthermore, it verifies that necessarily push the parity from the target metrics that are merely reflecting an underlying correlation with different sparsities levels. Okay. This is the encoder weights to evaluate a suite of both common and novel sparse equations the open source library, the dictionary learning from this page. But is this the I think? Well, look at it from that paper. Interpretability. So they do this is basic one. No, I do it without that. Materials batch top K. This started to sound like large model names with like the Omni plus K. That's okay. Gated, Jump Value, and Pianili. Okay, so they don't do trust coders. Maybe because they work differently. Have to. I don't remember how trust coders work right now. Need to ask Gonzalo later if he thinks you could just run the trust coders on this and see how good they do. But yeah. I think they maybe just use more than one layer. That's why it's not directly compatible. We train multi-variants with and sparsity. I guess. Oh, L0. Also, they might just use. I guess it's also the okay. It's different depending on the different. But original stream activations on time at the middle layers of Gemma 2 3 and Pythia 170. Is this model open source or they does
Yeah, Gemma 2
yeah.
Google model answers. In fact, Google released Gemma scope that trains of size on that model.
Oh yeah, but I wasn't sure if they. Yeah, I guess they trained this raise the size they have to replace it. Or they will only let you access through an API or something like that would be but yeah. I wonder how you can reconstruct a bunch of sporting colors. Probably not a lot because you don't get. You have the activations, not the weights. I tried activations for a lot of things. We will open source the suite of over 200% colors upon completion of the peer review process. Further details are contained in Appendix B. In addition, we evaluate this person colors with 16 days, this is and 1 million on Gemma and a bigger Gemma from the Gemma scope series. Yeah, they're just using the Gemma scope. So yes. Now, key takeaways are the different paragraphs. Wait, let's look at the results. The university, loss recovered. Yeah, you need at this point you are basically with 10 to the power of 3, you are basically just doing the model.
Sorry, what do you mean? What was it like a high person?
Like if you have such a high sparsity, you like to, first I don't know how width of the models on these images, but it's not that weird to recover most of the loss because first person covers the size of the model with basically no sparsity. The size of the animation. So the model may just learn to just do some linear transformation of the activations.
Yeah, it's an open color. Yeah.
It's not really. It's not even at this size. I don't know how the width is. If it's pretty big, it might not even be autoencoder. It must just be like just doing a matrix multiplication on the middle of the model because it's not even smaller. But yeah. saying here, auto-interp score. It's interesting that the auto-interp scores don't get worse with more until the more sparsity is until the end. Maybe that work can just. It's still not that good, but maybe the works you can just not do sparsity, just do autoencoder and try to interpret the latent, and that works. You wouldn't expect that to work in some sense, but maybe it does. I would also want to look at how the explanations look like exactly. But yeah. This is a sparsity and mean absorption fraction score, and it says I don't remember what mean absorption fraction score was. Yeah. And SLC I correlation thing. Also doesn't think. Fast probing top 1 test accuracy. Oh. It's kind of weird. Some methods. Yes, some methods do really become really good with more accuracy, and some don't. Mitigated for some reason. I don't know what gate is like. Like the ReLU does get there. I guess it's non-linear. If just using a ReLU, I don't know exactly how ReLU works. Just adding a ReLU to it.
It's highlighted in bold that the ReLU SAE is worse in performance in almost all the measures.
Also, yeah, on the other ones it's worse. Better. Yeah. So it seems like it gets pretty good. Like the top K really good at the interpret score for some reason. I don't see the data point for here. Maybe it's just so good this doesn't show up here.
Which benchmark is the most useful for seeing the accuracy? It's 6 different accuracy benchmarks for these SAE methods.
They measure different things. Okay, sorry, I was reading this wrong. I said that the early was the auto-interp. This is the sparse probing one. The auto-interp score, I think the score is interesting, though it's kind of not that good because we don't have like good language models to test it. And you need a combination of these things. Like if there is some single cool good metric, it might be some weird example of this, because if you could imagine something where you take the model without modifying anything, say that each of the activations, like each of the take all of the neurons and the neurons themselves, say, okay, so this neuron gets multiplied by this number, and you just split the math model, and that will get perfect score on depending on how if you allow, depending on how the details, how it works, you might get perfect up to 100% score of that, and well, not necessarily, but anyway. Well, yeah, no, because you're just one layer. But you might get perfect structure loss. But the model is still bad. That wouldn't actually explain anything from the model. So it will do bad all of the other metrics. So it feels like you want multiple things from the model, where if it's just good than a single metric, that might be bad because it's some weird overfit example where you can do really good at some metric at the cost of being bad at all of the others.
I think the point of the paper is that there is not a clear way and easy to measure the performance of the experts of the course. Yeah, they try it.
Yeah. My take on that is that maybe there is, but we don't have it right now. Maybe you can. Maybe you can use this paper and these metrics, but some other metric that correlates with all of them in some way. Or maybe the metric is just some sum of all of the metrics in some way. But yeah, I just do reinforcement learning on that, and it just works. It will be kind of hard to do with trying to interpret score because it's kind of expensive to query ChatGPT or whatever language model for each example, but yeah. So instead on this sparse problem thing, they say here that the ReLU size is bad in most of the metrics. Instead on this sparse probing for some reason. And the Matryoshka that's okay. Seems good on some of them. Seems pretty good on some of them.
Maybe like I don't know if sparsity is different from how frequent the activations are. Maybe, or is the sparsity 0 equal to the high frequency latent?
The sparsity is just how many activations are active on each. When people talk about different sparsities, they usually mean different zero or different penalties have more latency at the same time. More sparsity means trying to summarize the activation in less latents.
Okay. I'm a little interested in how the SAEs work with the high frequency latents and see which ones work the best and which ones work the best with like the low frequency latents.
Yeah, like when you are aiming for sparsity, you are, I think, getting there is not a lot of high frequency latents because there is no a lot of high frequency features because then if your model are going to have problem representing a lot of high frequency latents because if it has a lot of sparsity. But yeah. So was the other architectures perform reduction absorption? Yeah. Don't perform one metric. One is possible. Huh. I feel interesting if the people die a lot more of person they can find it and the of the other metrics are correlated, but one sparse probing and a learning rate. I guess those are related to having the model represent things in not a lot of latents or something, or like really separate things. a way we were talking about how they were related, like the concept of feature absorption and the completely necessary isolation. But I guess you can have like feature absorption and both these things in that you see that the sparse probing test and the other and the absorption thing, but does well on this, but does bad at the absorption test, like the sparse, like the one, because I guess like you will have maybe a problem because you have you want to probe for the concept of some letter starting with A. Maybe they not try training the model on a feature that is getting absorbed. That might just be. I guess if you were training on, for example, like they wanted to find the S feature in the previous example, you would find that it's lower accuracy that it will be because sometimes you need the snake feature to find it to represent this concept. So if you're training only on the high feature, is going to fail like 5 times or something. But that might just be a small loss of accuracy. And if you happen to be looking for some concept that doesn't have feature absorption, that just doesn't happen. This thing on this might just be on different concepts that are represented differently. Different frontier does reliably indicate performance of the instance. So this thing ranks different zero regiments. Zero is the norm, like the penalty on the loss to have high sparsity. Okay, jump, trios, pioneer, and relu performing the worst. Didn't they say that Patrioska's professors were bad in some way? Because these samples seem just good at everything. Well, I look for that. Let's finish the paper first. Maybe the spend it. As L0 increases to the middle regiment, this performance difference diminishes substantially. Most performance that of real and reduce person coders. However, this ranges the performance on other metrics. For example, here this main shows strong performance on LCR feature absorption, despite this median position with sparsity fidelity frontier. Similarly, while Pioneer consistently performs skated person coders on the absorption metric, that shows pre-performance on loss recovered. Maybe the explanation for this is the sparsity as a bite idea. You need something else that is similar but not exactly sparsity. And the Patrioska are just good. If they are just good at everything else and just bad at the sparsity thing, and they don't really care about the sparsity thing, it's just a proxy metric. Maybe the proxy is bad Matryoshka is, person code is pretty good. I mean, this makes sense that they do really good at the feature insertion because the feature also was created, like they were created to try to deal with this feature absorption, but not bad at loss and this the correlation scheme and the all that. Behaviors are mixed methods. You observe distinct patterns that share later fundamentally doesn't share the same. And for example, yes, with dictionary science architecture, the learning in dictionary both restitution and interpretable individual. Matryoshka is the only architecture improving on feature disentanglement with a scale. Okay. Was it more performant with scale was scanning for most creation methods that measure feature disentanglement and concentration? So I think that I don't listen to methods. Impulsing more granular and low level abstraction. The other single the code direction and method with the features and it is collaborating. Contrast, but there's assigned to the hierarchy the same multiplayer stage for this implementation. This structure is the positive script and there's trends. Okay. Like since the main thing we care about is something like interpretability, as well as like interpretability, a piece of interpretability. Maybe the reconstruction loss. No, that's also. So it's definitely. I'm wondering why this is not. Maybe we just scale a lot Matryoshka others and that works. But I don't see that. Yeah. In other words, today the same amount of staying data with the number of flops for personal. What if okay. Yeah, what the best after reconstruction? The best is rel with channeling, right? No, that's immediately. The one that actually good is the dated one, so maybe the best okay. But Matryoshka okay is not varsity. Maybe we just could do Matryoshka like low sparsity Matryoshka spectrum colors and they will work fine and split the model. I was no single L0 for other task. However, moderated zero strict numbers of various metrics. We valid points for 6K, okay, and regular passing codes of all this. has many meters of the performance by the amount of tokens, and all this so performance by and higher levels might be worldwide for liability size. Modest effects. Feature. Okay, but this is interesting. Feature disentanglement metrics show the suspended preference for higher L0 values. Very significant for the conventional LC range of the attack. This preference is particularly pronounced for type B. Well, it's interesting. LCL considered metric doesn't in this pattern. We hypothesize the highest possibility for the composition of multiple constants into figure RTI latents, potentially harming this entanglement. We do see some notable trends with case-pairs probing. It provides limited differentiation between architectures, with some specialties, which cause failure from domains. This aligns with findings for Gao et al. One that provides it is quite noisy. Supervised metrics are fundamentally elevated by algorithm of data. Supervised metrics can only evaluate contexts in related data, representing a it's something I was complaining about earlier, where you need some sense of what the representation should be to supervise the metrics, and that you might just be wrong about what the model is representing, or like what the how to divide the universe usefully or whatever. The natural ways of doing that. Different valid ways of this separating concepts and the others. You think they will back? Okay. Okay, several metrics. Reconstruction anti-white. What the metrics are not capture qualitative interpretability. Yeah, it's just a fake. Numbers might not be anything that doesn't be anything interesting in practice. Someone leave. I mean, I've been here for like more stuff soon. I wanted to finish the paper and keep getting distracted, but having thoughts about it. I should probably like try to read the paper beforehand more times. But I think it was an interesting reading group anyway, and some people said some interesting things. I wish Sandro was here to talk about his scholar stuff, but I asked them other point. Revelation covers specific models as well as there is a language models architecture. Yeah, obviously. These are other things that printing the reviewers, I think. Metrics cannot meaningfully combine into a single score. Why not? I really was saying that. That's my principal interpretive reconstruction accuracy. Accuracy or metrics operate on different scales and served by numbers of noise. When this comparison, I tend to compare was arbitrary weighting choice and the poor score. Okay, maybe arbitrary. Maybe it doesn't just work. Just someone something like using a single metric that there's some weight of these metrics and see what happens. Although it may be better to look at those for results. Some of the metrics correlate than just pointing to the same thing, and you might find some metric that is just a combination of only one or two or something that are or some other thing that generalize them. And conclusion, this is how color is, whatever. Yeah, they just talk about that. Anything optimal party levels by different times. Well, this is true, but if I understood correctly, this is not true for battery particulars, maybe? No, the sparsity. Not most metrics improve with higher sparsity, except maybe out of scores. Well, some actually go bad at the end. That's what you were saying on the middle. Yeah, this is not a lot of sparsity. 100. Well, you don't have more than 100. Yeah. Compressible knowledge of multiple places when the problem was sources of coding. Architectures where the field has primary focus on the sparsity, fidelity, trade-off. Results suggest that non-state performance are not imperative for practical applications. Yeah. Okay, so the three main things like you have reconstruction laws, how well you can reconstruct the applications. The feature disentanglement metrics, there is a bunch of them, and the task metrics like learning or whatever. And if you want the model to be good for all of them, so I could see that maybe you could have a good model that is pretty good at first two, that is pretty good at reconstruction, pretty good at interpretability, and that will be pretty good. And if a model that's really good at both, but is bad at the tasks, that may say something about the task not making sense in some way. That model being the percent other thing may bad. But yeah. It was made for maths. There is a lot of apprentices, and I want to look at some of them, but I think the reading group has been like we've been going for too long already, so I'll probably just skip it here. Yeah. There is also the web page, which looks pretty cool. You can look at the different metrics and see how they correlate. I find interesting that the sparsity doesn't matter much for the. It does matter, it gets worse. You can. It's not as bad as for other metrics like the sparsity with the auto interp score. Though the scores may be in general though.
But after
going to say
it might be bad, but it starts to get worse as the market increases.
Yeah, I'm not sure what 0.99 auto-interp score. In this context, like my impression by looking at the from seeing and looking at the explanations on the on the different on neuropedia or whatever it was called, is that the auto-interpretations are not that good a lot of time. But yeah, so maybe like this 0.9 is not that useful, or like it's misleading. It's actually pretty bad, but I'm not sure. I will check exactly what it means. And, yeah, and like the you can generate a good explanation doesn't mean that the auto-inter score is like that the model is interpretable, because you might just be overly summarizing the model. You just you have this is instead of have some the model have some complex structure about different math things, and you're so high sparsity that they just get summarized into a math feature, and the model just has the auto model just has to say, okay, this is a math feature. I always activate some math, but you didn't really actually understand the model. Lower level of abstraction is more interesting than that. Yeah. Anyway, anyone else has anything to say before I just stop the recording and all that? Stop it. Wait a bit, yes, and otherwise I'll just speak.
Do you have any resources for the Matryoshka SAE? That one is interesting because it performed the best on most of the benchmarks.
Yeah, I think part of it that the benchmarks have like these entanglement things, and the Matryoshka, it doesn't perform the but I think that some of the metrics were invented for. I think they were invented for Matryoshka Baker, but they were like the Matryoshka was trying to solve them, and maybe just if you had a more complete set of metrics, it wouldn't do as well. But yeah, I think it's interesting, and maybe it turns out to be really good. You can just look at the Matryoshka essay. Yeah, this was a written paper, and the authors, I think, were on the group. It might be on the recordings. I'll look for it later. But yeah, anything else, or can I just stop the recording now? Okay, I guess I'll just stop the recording.